I want to do a short video today on doing a slope analysis for a defined area. And in the state of Pennsylvania, the way that we're going to do this is we're going to be using LIDAR-based DEM, and we're going to be talking about a few of the challenges with that to make sure that what we do and what we get out of our analysis is appropriate. First thing we want to talk about is what kind of slope we're interested in. And in order to do that, what I want to show you, just bring this over, this is how ARC defines slopes. That's an important idea. When we talk about a 3-to-1 slope, in other words, we're looking at that 33% slope, what we want to make sure is that we're dealing with units that are both horizontally and vertically equivalent. And so again, ARC, if you're using ArcGIS, the idea of percent slope is what we're going to be working from. The next piece of this I do want to point out is that in Pennsylvania we're going to be downloading DEM files that are tiles. And so if we look at PASDA, which is our Spatial Data Clearinghouse, what you'll notice is that there are two tile indexes that you're going to want to use, and they're right here, Tile Index North and Tile Index South. The advantage of both of these files, and I've extracted them and I'm going to add them now to a map, and here they are. And you'll notice that we have here PA North and PA South, two sets of grid files. And in this case, we're going to be looking at a study area right here. And this series here, again, we have an area here that we want to block out. It encompasses 1, 2, 3, 4 grid cells. Now the advantage of these index files is that if I use my identity tool, I'm going to click on that here, I'll show you what you get. I click on one of these, and what you'll notice is that there are FTP links directly in the attribute table. So what I'm interested in is this one right here, and if I click on that, you'll notice right over here it has a hot link, and so when I click on that, it actually will download. You'll notice it right here, downloading. Now again, I've already done that, and what we get, and I'm actually going to download one that's a little bit different, one that we don't need. The reason I'm doing that, I want to show you one of the challenges of some of this data. And when this is done, what I'm going to do is I'm going to extract that because one of the problems with Pennsylvania data is, well, I'll show you. Hold on one second, and we'll move that. I'm going to extract all of that. I'm going to put it in the area that I'm working on, which is in my E drive, and we're going to be working with LIDAR data here, so I'm going to stick it in there. And in this case, again, I am going to say extract to that. Now what I want to do is I just want to add this single file, and the one that I just extracted is the 240 file, which is right here. I'm going to add that, and what you're going to see, I'm going to turn these off, and here's the data file. Now you'll notice that in fact it has, its horizontal units are in feet, but when I click on a vertical value, one of the problems with this is that we're going to go to catalog now, or in this case I'm going to just open up its properties. The source data in terms of its coordinate system, you'll notice it has an X and Y coordinate system that's NAD 83, State Plane, Pennsylvania, North, and it is in feet. That's great. But its vertical coordinate system is not set. If you don't do that, it is in fact in feet, but the computer doesn't know that. And in ARC, it's going to default to using a meter coordinate system. And you need to make sure that we don't have that happen. So we're going to go through the steps now. I'm going to turn this one off. And so we've got these pieces here. And what we're going to do next is I'm going to walk through it from a model builder standpoint and talk about what tools you're going to need to do. The first thing that we need to realize is that when we look at our study area, and again I'm going to bring this up here, what we have is a fairly complex study area. that covers several grid cells. So the first thing we need to do is get those grid cells together. And the way that we do that is through the tool that is Mosaic to New Raster. I like to use this tool because, again, it makes, at least when you're using a relatively small number of tiles, it makes for a much easier single raster data set. So again, we're going to Mosaic to a new raster. Before we do that, however, in each of these, what you need to do is go into Catalog, and what you're going to need to do, you'll notice here is my raster data sets, and I'm going to refresh this so that we see that new one here. And if you notice this, I'm going to go into its properties, and it does not have a vertical coordinate system, so I need to set that. So what I'm going to do is I'm going to go into the spatial reference, click on Edit, click on my Z coordinate system, and I've already looked at the metadata, and so I know that this is NAD, North American datum of 1988, and we're going to be interested in the height. So I'm going to set that and apply it. Okay. Now, once I've done that, the next tool here that I want to kind of focus on, again, is this Mosaic to New Raster. So what I'm going to do here is, in this tool, when you run this tool, what you're going to do is input your raster data sets, and again, you get them from the drop down here, and then you're going to set them to a new location. Make sure that your output raster type is at least 32-bit float. What that will allow you to do is have both positives and negatives and decimal places. It defaults, unfortunately, to this 8-bit unsigned, and that will not get you anywhere. That will give you integers, and that in a sense ruins your data. So we don't want to do that. All right, the next thing that we're going to do, when we do that, so when we mosaic it to a new raster, I'm going to add that piece of information here, and what you're going to get out from that is going to look like this. And let me move that out of the way, and now we have a single data set that covers our area of interest. Wonderful. So now the next piece to that is to take that, and we're going to calculate slope. And so again, excuse me, our slope tool is going to be, we're going to open that up right now, and now that we've set our units, so our units are 1 to 1. Okay, we've got feet horizontal and feet vertical. We're going to output that, and in this case what we want is a % rise, and we're going to assume, because we have a relatively small area, that it's a planar method of calculating it. Okay, our Z factor, now if we had meters in elevation and feet horizontally, what we would want to do in terms of our Z factor is we would want to change this to a factor that would calculate or compensate. So for example, if I had meters vertically and horizontal feet, we would want to use something like a 0.3048 conversion. We type that in here. But in this case, because I've used meters, I've defined it, and it's feet and feet, we don't have to do that. We need to put a 1 in there. And so we're there. And once we calculate that, move this out of our way, next step, what we come up with, again, is our slope. And I'm going to add the slope right now. And we'll give it a little bit better color scheme here. And we'll do a low slope to high slope, something nice and green to red, kind of our standard here. And again, not surprisingly, what we can see is that as we drop into some of these valleys, we have fairly substantial slopes here. The other thing that we want to look at is to see what our slope values are. And again, there's some extremely high slope values here when we look in here. Okay. So 117, okay, it's a pretty high slope value. And again, if you think about that, what 117 means is essentially a 45-degree slope. Okay, 100 is a 45-degree slope. So that's a pretty good slope, but that's about right for that area. Okay, you always want to kind of look at it and say, well, does that make sense to me? So now we've got our entire slope area. We'll go back and we say, well, we don't want all of that data. What we really want then is to cut that out. Okay? But before we do that, what I'm really interested in is simply identifying those areas that meet the criteria of greater than or equal to that 3-in-1 run, three unit run versus a 1-unit rise. Okay, 33% slope. And so in order to do that, I'm going to use a raster calculator. And I'm going to open this tool up. And again, in here what I've done is I've said, well, I need my slope to be greater than or equal to 33. And when ARC calculates this type of slope, it does multiply it by 100. So rather than being 0.33, you have 33. And so I've put that in, and there's my output. And what we're going to get next, okay, so that's our raster calculator. So we've done our slope, and then I want to essentially classify it as greater than or equal to or less than. And so now let me add that part back in. And we're going to see it here. And what we see, again, not surprisingly, I'm going to right here, we'll kind of look at that, is that the areas in blue meet that criteria, the areas in gray do not. And again, not surprisingly, we get this 100% slope here, and we can see the areas that are 33%, you know, in here, and so that's our blue areas here. Those are our big slope areas. Now again, what I want to do is I'm going to go out to our overall study area, and here it is. And what I'm going to do is make that a little bit hollow so we can kind of see what we got. And so there's our study area, and you'll notice that there are some areas here of fairly high slope. And again, makes sense right here, makes sense right here. Everything looks about right. The next piece that I want to do then is clip that out. And so again, what I'm going to use is, rather than in a vector sense using the clip, what we're going to use here is extract by mask. And what I'm using then is the study area boundary as my analysis mask. Again, I'll open up this tool, and you'll notice that my input mask is the boundary. I've put in my greater than 33 raster data set, and my results are going to come out of that. And so the result of that extract by mask is going to look like this. And there we have it. So I'm going to turn off my general data sets. And now I can see that from my original raster, these are my areas. And in fact, what I'm going to do is turn this to a nice, that purple is kind of a nasty color there. And now we can see the areas in this study that are in fact greater than that slope. And that's what we're really interested in. So that's making a analysis of greater than 33% slope in a study area based on multiple DEMs from in a sense, a catalog. So again, basic tools, basic sequence here. Let's just walk through it. First of all, I'm going to mosaic my rasters to a new raster data set. I'm going to make sure before I do that, that in the case of all of my inputs, that the vertical and the horizontal units and coordinate systems are defined. We're going to do that in the catalog. We're going to go into the properties, and we're going to define the vertical datum, or the vertical coordinate system, excuse me. Once we've got that, we're going to mosaic it, and then the mosaic data set, we are going to calculate the slope. And in that case, we're going to be calculating a percent slope. When we move into the raster calculator, then we're going to ask for that calculated area, those that are equal to or greater than 33. From that, we're going to use the extract by mask tool to then clip out only the area that we're interested in. So there you go. Basic slope analysis for a defined study area. That's all for today.